And the deep learning domain, the foundation of deep learning domain is all about neural networks. So we will have detailed lecture on neural networks, because if you don't have the clear understanding of a neural network, then it will be very difficult for you to understand the algorithms related to deep learning domain, right? So it is very necessary that we have a detailed discussion on these neural networks, and I will also share some practical examples with you. So all these algorithms are related to supervised learning domain, and in most of the applications these algorithms give very good performance. Now let's have a look on the unsupervised learning domain. So as I told you, that unsupervised learning domain is usually used when we want to make groups or clusters of the input data, and those groups and clusters of the input data are basically based on the characteristics of the data samples, right? So the target is to group those instances or examples together which have similar attributes or similar characteristics, right? So in that case, we don't need the specific label for each training sample or instance, right? Because we are determining the underlying characteristics of each training instance. So that's why we are able to create clusters and group in unsupervised learning domain. So the most classical unsupervised learning algorithms are PCA, which is an abbreviation of principal component analysis. Principal component analysis also has its major contributions in dimension reduction, and because sometimes if we have data with huge volumes, then it is not feasible to train the model with such huge type of huge scale of data, right? Especially if you have limited resources both in terms of memory and processing, because the huge and large volumes of data will cost you not only in processing but as well as in memory. You will require more storage space, and your algorithm will require more time to train. So in that case, PCA can help us to reduce the dimension of the data, right? We can get rid of, we can, PCA basically works on the principal components, and we are looking for some eigenvalues and eigenvectors, and with the help of that, we extract principal components from the data, which ultimately help us to reduce the dimension. Another classical example is the k-means clustering algorithm, right? Which is being used in many applications, and it gives very good results, right? In k-means clustering, k is basically the number which determines that how many clusters we want to make from the input data set, right? And selecting the value of k is also very crucial and critical. But when we have a lecture on k-means clustering, then we will see all its details, that how do we know that how many clusters do we need to make, and what is the optimal number, and how we use different kind of similarity measures in k-means clustering. So all these things are related to unsupervised learning domain. Other common algorithms are SNE and DBSCAN. So people are also use these unsupervised learning algorithm. Now, the third thing is the reinforcement learning. I told you that in reinforcement learning, we are basically using our environment to have a feedback and on that feedback, we basically we make decisions about our agents. And the most common approach is Q-learning and SASA as well. So we will also look in uh, detail about some classical reinforcement learning examples. Now, so what do we need to do is that we need to make proper algorithm selection and its training, right? So for any specific application, if we want to develop a successful solution for a specific problem with machine learning, then these two things are very important, right? We need to make proper selection of a proper algorithm depending upon our use case or our application. or the nature of the data self itself, and we need to make its a proper training mechanism for that, right? So we can select an algorithm from the three domains which I have shown you from previous slide. You can select any algorithm and then we can go for the solution. So the goal of training is basically making the correct prediction as often as possible, right? So what we are looking in the training part, or the purpose of the training part, is that we want our classifier to predict correct values, right? We want it to make correct decisions every time as much as possible. So if we have correct a good training, then we can expect that our algorithm will be making correct predictions. Also, this can be an incremental process, right? The improvement in your algorithm can be incremental. This incremental improvement means that we can switch back to prediction and adjustment of the parameters, and we can basically iterate in this procedure, right? So on the basis of predictions, we can improve our parameters, and with improved parameters, we can expect to have improved prediction or correct predictions, right? So use of metrics for evaluating performance and comparing solutions. So we use a number of performance matrices in order to evaluate or in order to measure the performance of our algorithm. And most of the most commonly used evaluation parameters are basically accuracy, sensitivity, F1 score, and we also use area under the curve and some related parameters. So we basically make a confusion matrix, and in that confusion matrix we see that how many false positive we have, how many true positives we have, and some other things. So we will be looking in these performance measures in detail. Hyperparameter tuning, one and art than a science. So this is a very important thing for all machine learning algorithms, but more related to the neural networks or deep networks, right? Especially in the field of deep learning, the hyperparameter tuning plays a very major and very important role, right? So because if you have the parameters or the hyperparameters correctly or finely tuned, then your algorithm will be performing very much better. On the other hand, if there is not proper tuning of the parameters, then it will be difficult to have good results from your application. And the interesting thing is that the tuning of the hyperparameters is more of an art than a science, right? So what you can do is you have a bunch of parameters, and basically you mostly do a hit and trial rule to see that on what values your algorithm is basically giving good performance, right? And on that basis you can select those parameters. So this is a very important field, these two things, evaluation matrices and hyperparameter tuning. Again, we will be looking in detail these two things when we will reach to that point. Okay, so let me explain to you now that because now you have the basic understanding of most of the basic features. So let me explain that what we are doing in the training phase and the prediction phase, and I think that all these modules will be making more sense to you now. So let's have a detailed look on this figure.